Okay, we did up to this polydentate. Now there is another type of what we say ligand, that is called ambidentate ligand. So we will talk about that as well. First, wait a minute. Ambidentate ligand. See, what is ambident ligand? Basically, there will be two donor site in a molecule. There will be two donor site. That means it can donate from two site, but it will donate only one at a time. Okay, that type of ligand is ambidentate ligand. So I can write the definition. Ligands which can bind through two different atoms or sites. Which can bind through two different atoms or sites. But it will use only one at a time to form coordinate bond. So very simple it is, as you know that it will have two donor site, but it will use only one at a time. That type of ligand is known as ambidentate ligand. Example is very important, as we can see NO2 minus or SCN minus. Now I'm going to show you. You can see an O negative and double bond O. This will have a lone pair. So you can see either it can donate from this side or either it can donate from this side. That's why it is two donors. So you can write like this, and this is your O negative and this is your double bond O. So it can donate from this two metal or it can donate like this. In the same way, SCN have the same SCN. So it can donate negative charge from, that means sulfur, and it can either donate from nitrogen has lone pair. So this can donate from this. So it has two donor site, but it will donate from only one side. That is called ambidentate ligand. So I think it's clear to both of you, right?
Yes.
Okay, please do write it.
Internship.
Very good, both of you. Now we are going to, as I told you, oxidation state of central atom is very important. So you can easily calculate if you know the charges of these ligands. As we already classified the ligands on the basis of charge. So just wait a minute. Yeah. So when we did this classification on the basis of charge, so you have to take care that NO. If NO is there, that means +1. So the oxidation state of NO will be +1, NH2 plus. NH, this is very important. NH3 oxidation, it is neutral ligand. So whenever NH3 will be there, so it will be equal to 0. En, ethane 1, 2 diamine, H2O, CO, carbonyl, alcohol, amine. These all will have neutral. That means oxidation state that you are going to take is 0. Cyanide will have -1. Cl minus, I minus, Br minus, F minus. C2O4 -2. This has charge -2. This has -1. So this is, you need to keep it in mind. Is that clear?
Yes.
So I'm going to show you one of the uh, question I'm going to write. Find the oxidation state of central metal atom. Central metal atom of following. First, I'm going to show you, and then you are going to do it. Okay. So the first that I'm going to take is K4FeCN whole 6. Whole 6. Now see, when you are going to solve it, you need to calculate which one is central metal atom. Everyone knows this is your central metal atom, right? Or ion. So in order to calculate the oxidation state of central metal atom, let the oxidation state of central metal atom is X. Now there is potassium. Can anyone tell me what is the oxidation state of potassium? This is a metal. So it will be positive. As I told you, the left side just before bracket will be positive counter ion. This will be positive. So everyone knows that potassium from first group, and it has oxidation state of what? +1. How many potassium is there? 4 potassium. So 4 into +1 plus X plus. How many cyanide is there? 6. And each cyanide is how much charge? -1 will be equal to, is there any charge that is reflecting on the surface of this or on this molecule? No, that means it is 0. So you just need to apply the basic maths and solve it. So what you will get, X -2 will be equal to 0 and X will be equal to +2. That means the oxidation state of central metal atom here is your +2. Is that clear?
Yes.
Okay, very good. So now I'm going to give you some questions. Wait a minute. Okay, let's just start from his. And as I told you, this En means ethane 1, 2 diamine. Oxalate ion, if you remember oxalate ion, generally they don't give you C2O4 -2. They can give you in this form OX. You have to understand this is the representation of this, and this C2O4 is this. So I'm going to give you, you just need to calculate OX whole thrice, the oxidation state of central metal atom. Please do it. Very good, Austin. Humam, any answer?
1 minute.
Okay, I'm going to give you one more question. Very good, Humam. Just solve all the oxidation state of central matter atom, and then I will write the answer. And if there will be any mistakes that you have made, let me know. I will explain that. Okay.
Yes.
Okay. Let me know when you are done with this. So I'm going to write the answer. Here it will be in +3 oxidation state. Here it will be in +2 oxidation state. And here it will be in +3 oxidation state. And here it will be in +3 oxidation state. And here it will be in +2 oxidation state. If any doubt out of this 5 questions, just let me know. Omam and Austin.
Yes.
No doubt.
All of it is correct, right? This is your carbonate, CO3 -2. That's why this is your -2 and this is your -1. So -3 will be on the left hand side. When you are going to keep it on the right hand side, it becomes positive. This will be neutral. This is also neutral. This is neutral. This is -1, -1, -2, -1, -3. So becomes positive. OH is hydroxide, negative. This is +2. So I'm going to write another. Just let me know what is the oxidation state of this central metal atom. Let me know. Good, Austin. Umam. Umam, any answer?
Okay.
What did you say? What is the answer?
1 minute.
Okay. This is very easy. You should not take this much time. See, copper, we need to calculate. So X. How many ammonia is there? 4. But you know, ammonia is neutral. So you are going to put 0. And there is no one, no other component is there. So equals to. What you are going to write, as you can see, there is positive charge, +2 charge is there, so you are going to write 2, because in this all the compounds there is no charge, that's why we put 0, that's why we put 0, but here it is +2, so 2. So you can see X will be equal to 2. So the oxidation state of copper here will be +2. Got it?
Yes, sir.
Okay. Now can I change the slide?
Yes.
Okay, now there is another type of ligand that we should discuss first, and then we will go towards nomenclature and all. Chelating ligand. Are you aware of this chelating ligand? Yes or no?
Oh,
Austin?
Yes.
So ligands, the ligands resulting in closed ring structure. The ligands which forms closed ring structure with central metal atom or ion, central metal atom or ion are called chelating ligand, are called chelating ligand. So as for example, if I'm going to show you, if CuEn whole twice raised to the power +2 is there. So I'm going to draw the structure. This is your central metal atom and En is twice. That means I'm going to write En, one of the En on the left hand side, right hand side, and one of the En on this side, left hand side. Now you can see CH2NH2, CH2NH2. Now this is your lone pair. So this will be like this. This will be like this. Lone pair. This will be like this. And this will be like this. So you can see there is formation of closed ring. So this type of ligand is basically known as chelating ligand. +2 will be there. Is that clear? Please do let me and write it. Are you done with this, Humam?
Yes.
Okay, so this is chelating ligand. Now we are going to start a new topic. Basically, in this topic, we will know how to write the formula of complex compound if name is given. And after that, we will start IUPAC, how to write the name of the compound is formula is given. Always remember that this counter ion, whether it is positive counter ion or whether it is negative counter ion, also known as a spectator ion, I told you, this is only used to neutralize the compound. This is only used to neutralize the compound like CuNH3. If you have seen 4, if there is +2, so to neutralize this, what you are going to do? You are going to use 2Cl minus. You know that 2Cl minus, when it comes, it will go like this and it will be neutral compound. You can see FeCN whole 6. This compound is like this, -4. So in order to neutralize this, You are going to use 4K plus. So this number can be variable. And this is this number can be very variable, and you have to be careful when you are going to use this. And if you know how to calculate the oxidation state of central metal atom, according to that, this number will change. Are you getting my point?
Yes.
Okay. So we are going to start this. Just wait a minute. Okay. So see what I want to tell you. Okay. Write the topic. Rules for writing formula. Rules for writing formula. How do we write the formula? Okay. So the first formula you are going to write with me, because it will be some 7 rules are there. So you can write with me. The central metal. First, I'm going to write it and then I'll explain. Atom is listed first. Then I'll give you example. We can skip this part, but for longer time, you should write it. For revision, you just need to go through this once and you will get all this. Ligands are then listed in alphabetical order. In alphabetical order. And their placement does not depend on their charge. Basically, it depends upon the alphabet. The next rule we can say, in case of abbreviation, as you know that like En and Ox, in case of abbreviation, or we can write in more correct ways, abbreviated ligands the first letter of abbreviation, the first letter of abbreviation is used to determine the position, Like in En, we use E in alphabetical order. Position of ligands in alphabetical order. The fourth, entire coordination entity, that means central atom and ligands, is closed within a square bracket. Within square bracket. This is your BR. Within a square bracket, whether charged or not. Whether a square, basically, entire coordination entity is enclosed within a square bracket. If there is charge, you can write the charge on square bracket. If not, then you don't you no need to write the charge, whether charged or not. The fifth rule, I can write polyatomic ligands like CO3 minus 2 polyatomic ligands are enclosed in parenthesis and also their abbreviation. If more than one atom present in a ligand, then you are going to close this in parenthesis the way I did this in nomenclature. If you remember, this is your polyatomic ligand, so I put it in parenthesis En parenthesis E. See, are you getting my point, all both of you?
Yes.
So the rules are very easy. I'm just writing it only. You can understand it without writing, but after completing the chapter, doing other chapters, might you might be forget about this. So that's why at that time you can cover it. Oh, wait a minute. You can cover by yourself. That's why only I'm writing it. Fifth, and then comes your sixth rule. Very important. No space is left in between. I am writing B/W between. Oh, wait a minute. Let me write the last rule. Then you can write accordingly. Names of ligands. And central metal ions or atoms. You can write anything. It can be metal or atom or ions. No space is left in between the names of ligand. That means and central metal atoms or ions. Okay. The next one. Charge positive or negative charge is counterbalanced. Counterbalanced. If counter ion is there, then counterbalanced. Just wait a minute. The central metal atom is listed first. Okay, write it. Then I will give you some example. Let me know when you are done with this.
Again, hold on.
Yes. Well, let me know when you are done with this. Are you done with this?
Done.
Austin.
Done, sir.
Okay, see if there will be name of the compound like this. Let's say example I'm going to take tetra amine, tetra amine, aqua chlorido, cobalt, 3 chloride. Now see how you are going to deal with this. As I told you, always remember that this part is negative counter ion. If there will be a space, that is after central metal atom, you can see this cobalt 3, this is your central metal atom. Okay. And if there will be something and then a space something, then that will be positive counter ion. Are you getting my point? That means basically if this is your square bracket, and if there will be something that will be written separately, then there will be some space, and then this part will be written together. Okay, and if there will be something, then there will be some space and written later. Are you getting my point?
Yes.
Okay, so first of all, if you are going to see the rule, they said that look at the central metal atom. You are going to list it first and write the square bracket, and cobalt is here. Okay. Now this is your amine, that means NH3, and you can see amine A alphabetical order, aqua, then aqua, that means H2O, and chloride, that means what? Water. So what I'm going to do, this is a polyatomic ligand, so CuNH3. Tetra, that means NH3 whole 4. Then comes your aqua, and then comes your chlorido, and then a square bracket close. Okay, are you getting my point?
Yes.
Now what you need to do, very simple. There is chloride, and this chloride is not fixed. Basically, you don't know, basically there will be one chlorine, Cl1, Cl2, Cl3, Cl4, that will be depending upon the oxidation of cobalt. So here this counter ion, as I told you, it depends upon the oxidation state of the central atom. So let's say for the right now it is Cl1, only one chlorine is there, and then what you are going to do, calculate the oxidation state of cobalt according to this formula. This will be X plus, you know that 4 NH3 is there, and this is a neutral ligand, that's why 0, plus 1 H2O is there, and H2O is also neutral ligand, that's why 0, and then plus chlorine is there, which is -1, and plus chlorine is 1 there, which is -1, and according to this formula you will be getting X is +2. That means the oxidation state of cobalt is +2. But in the formula, in the name, you can see the oxidation state should be what? +3, yes or no?
Yes.
So what you need to do, you have to make it Cl2. And if you are going to make it Cl2, then there will be 2 chlorine, and then this becomes X is equal to +3. And this is the correct formula for the given name. So after, you are not going to directly like Cl2, Cl3, you are just taking one and calculate the oxidation state according to this formula. Then you will see that there will be something change, and the change will be always from the outside bracket, not inside bracket. You cannot change the number of this. This will be fixed. Ma'am, are you getting my point why I took Cl2?
Yes, sir.
Okay, please do write it. And then I'm going to give you some questions from NCERT first. Let me know when you're done with this. Any answer, both of you? No, Austin, it is not complex. Anion not complex. Anion is not the complex. Okay, I'm going to explain. First of all, what I told you, if there will be some space, then this will be outside of the bracket. And on the right hand side, if there will be some space, this is also out of the bracket, right? Like in the case of chloride. So what you need to do, focus on this part. This is your zincate. That means central atom is your zinc. Okay. Now only one ligand is there, that is hydroxido. That means hydroxide. That means basically OH, and tetra it is whole 4. And potassium is there. That means this is a positive counter ion. I'm going to take 1K only first. Then according to this formula, if you are going to calculate the oxidation state, what you will get, you can see hydroxide is a hydroxide, 4 hydroxide is there, and one has -1 charge will be equal to 0. So X you will be getting +3. X you will be getting +3. And here it is +3, right? Yes or no?
Yes.
And
Just wait a minute. Did I write something? Okay, okay. Basically, okay. So according to this formula, this is correct. Okay. Humam, are you getting my point?
yes, sir.
The rest three I'm going to copy paste rather than waste your time. So if you it is an anionic complex, Austin. If you are not going to write it, it will be anionic complex. There will be negative charge. Okay.
Yes.
It is an anionic complex. That is correct that you asked. Now write the formula for all this. Humam, any answer? So indeed, there is no counter. Yes, if there is no counter ion, then you are going to write positive or negative sign on a square bracket according to the requirement of the central metal atom's oxidation state. Are you getting my point, Austin?
Yes.
Yeah. Yeah. Okay, I'm going to write it. First of all, what you need to do, there is a space. That means this is your positive counter ion. And trioxylato aluminate, that means aluminum. So there is aluminum. And you can see trioxylate, that means OX whole thrice I can write, right? And raised to the power this, no other ligands are there, so it will be closed. And now I'm going to put potassium 1 and then check the oxidation state of the central metal atom. This is X, this should be +3 according to the name, and 3 into -2 because oxalate has -2 in the -2 charge on it, and this will be +1. So you can easily find out that X, it is giving +5, but we need +3. You need +3. So what you can do, K3, if I'm going to put K3, what it will be, +3 plus X minus 6, that means it will give you +3. So this is the correct formula for this form, for this name. Is that clear? Is that clear, both of you? Okay, please do write it. Let me know when you are done with this.
Done.
The second one done, D. So I'm going to write the name of the D as well. Dichloridobis, there is no space till this, that means there is no counter ion. Okay. So first of all, you are going to focus on central metal atom cobalt. Okay, after that, dichlorido, that means Cl2. And then after that, you have ethane 1,2 diamine. That is your complex ligand, that is En, if you remember. En, that is, so En hold twice and there is no counter ion. Now you are going to check the oxidation state. This is X plus 2 chlorine is there. Each chlorine will have -1 plus 2 En is there and each one will have 0 equals to 0. So X will be equal to +2. But in the name, you can see the oxidation state will be +3. It should be +3. So what you can do, and there is no counter ion to balance it. So what I'm going to do, put positive here according to the requirement. Now, if you are going to calculate the oxidation state, now what it will be, X plus 2 into -1 plus 2 into 0, that will be equal to +1. There is positive charge, that means +1, and now it becomes +3. So according to the name, this is the correct formula. Okay. Have you got it, Humam and Austin?
Yes.
Yeah.
Hmm. Yeah, let me know when you are done with this. Any answer? No answer for this E1. Austin, Humamon, then Austin.
No, sir.
Okay, no problem. Is there any counter ion in this compound? Yes or no?
No, sir.
No. So what is the name of the central atom that is present in E?
Nickel.
That is nickel. So you are going to write nickel, right? Now, do you know carbonyl? What is the carbonyl ligand? I told you CO. CO is carbonyl and it is what? Tetracarbonyl 4. And oxidation state is 0. So if you are going to see in your types of ligand according to charge, this CO is neutral. So if you are going to check it, x plus 4 into 0, that will be equal to 0. X is equal to 0. So this is the correct formula for tetracarbonyl nickel 0. Okay. Everyone done with this? Oh, mom, are you getting it or not?
Yes, sir. Got it.
Okay, first you are going to write the oxidation state of central atom in all of this. Very good, Austin. Very good. Umam,
Doing so. 1 minute.
Write the formula for these four compounds, please. Any answer? Mom, Austin.
Done, sir.
Okay, I'm going to write the answer. Please check it. So you know that this is your potassium, this is your positive counter ion, tetrachlorido that means palladium, Pd, and tetrachlorido, that means Cl4, and potassium is here. Now, if you are going to check the oxidation state, it will be this is +1 plus x minus 4. Directly, can I write 4 into -1? That will be -1. So you will be getting +3, but you need +2. So what I'm going to do? K2. So is this the answer that you have got for the second one? This one?
Yes, sir.
Now, for this one, Homam, have you got the right answer?
Yes, sir.
Is there any counter ion in this? Diamine, dichlorido, platinum. Platinum is Pt. Diamine, that means amine is twice. And dichlorido, that means Cl2. And then you are going to write this. You don't, if you are going to check it, it will be x plus 2 into 0 plus 2 into -1. That will be equal to 0. So x will be equal to +2. That means getting the same answer. This is correct. Got it? Now the third one, potassium. There is counter ion potassium. So I'm going to write K here and then tetracyano, cyanido, nickelate. Nickel is there. Tetracyano. Cyano is what? Cyanide. We are talking about Cn whole 4. And the oxidation state is 2. So if you are going to check right now, you will get +3. So what I'm going to do, I'm just going to keep it 3. Sorry, 2. So now if you are going to check, this will be +2 overall. This will be x and this will be -4 will be equal to 0. So x will be equal to +2. So this is your correct formula, isn't it? Both of you.
Yes, sir.
For this one, pentamine nitrito. Nitro is basically NO2. Okay. O cobalt. I will explain. This is basically what we say. This is a uh, ambidentate ligand. So we have to show in the formula or in the name that which one is sharing the electron, which one is donating the electron. Since in ambidentate ligand we have two options. That's why. So first of all, there is no counter ion. Cobalt is there, so cobalt, and then pentamine, that means NH3 whole 5. Nitrito O, that means here in nitrito O is the donating ligand. So we are going to write ONO, and then you are going to check the oxidation state. If you are going to check pentamine nitrito O cobalt. Okay, now just let me know. Can I see? Pentamine, cobalt, NH3 whole 5, NO2. Nitrito is NO2, but NO2 you are going to write only when the nitro group is donating. But here it has been noticed that this is O, that means this is, you are going to write the formula ONO, so that everyone will be able to understand that the donating group here is O, not N. And you are going to do like this. And if you are going to calculate the oxidation state, this will be 5 into 0 plus 1 into -1 is there. So according to this, you will be getting x is equal to +1. But in here it is +3. So there is no counter ion. So what I'm going to do, write +2. And if you are now going to calculate the oxidation state, you will be getting +3. Is that clear?
Yes.
Very good. Write it. Let me know when you are done with this. Are you done with this, everyone? Both of you?
Yes.
Done, sir.
Okay, so in the next class, we are going to study about nomenclature, how to write the nomenclature. There are some rules. Now you can write the formula, right? Now I will be sending some NCERT based question to write the formula and oxidation state. In the next class, we are going to start nomenclature of complex compound. Okay.
Yes.
Okay, so this is it for today. Thank you so much. If you have any doubt, you can ask me. Austin,
Sir, no.
is there any doubt, Austin? Humam?
Also.
Okay, how is your preparation going? And one more important thing I need to discuss with you. Just hold on a minute. Yes. Can anyone tell me your in revision test, your upcoming unit test or any test in your school, this coordination compound completed or it's going on?
It's going on, sir.
Going
What?
on.
Going on, Humamuddin and Austin?
Yes, sir.
Okay, basically this is your there is a revision test in Learnivio in which solution is there, electrochemistry is there, chemical kinetics is there, haloalkanes and haloarenes is there, alcohol phenol ether is there, aldehyde ketones is also there. And this test, just wait a minute. On week 1, 8th September, that means tomorrow, you will